Welcome one and all to the Math Magic Show. In this one we're going to take a look at demystifying tangent inverse function. Again, this is perhaps a non-standard video for those who really love math just the way I do. Okay, so let's take a look here. The best place to begin is with the graph of the basic tangent function because we can use that for reference. So what I mean by this is the following. In this graph you have the usual horizontal axis, which represents often angles, and the vertical one, which represents essentially ratios, if you like. So now let's draw in the tangent function. These are a few pieces of the tangent function. Perhaps you've seen these. And let's take a look. So this is the tangent, and this is a function. In other words, it passes the vertical line test. Look carefully. Look. See, when you scan across with this vertical line like this, then as you can see, it will pass the test, right? Everywhere it goes, it hits only once, and once, and so on. So it passes the vertical line test. But there's an issue here with this tangent function, which is the following. Take a look. It fails the horizontal line test. Now, if you think about this very, very carefully, why do we have the horizontal line test? Let's just get to the reality and essence of it. It's simply because it's as if we were reading our graph from the vertical over to the horizontal. So, in other words, just think about this. From our perspective, it looks like a horizontal line I've drawn through the branches of the tangent function. But if I were measuring from the y-axis back to the x-axis, from the perspective of being on the y-axis, it would be a vertical line. I hope you got that picture. So in a certain sense, we call these two things different, tests, but in reality, if you read the graph from the vertical to the horizontal, then it's also a kind of vertical line test, you see? Okay, let's move on. So the issue is that this line here hits the graph in more than one place. So in other words, if I begin with a y-coordinate of 2, I don't know whether that came from doing this input or from getting it from over here, you see? Or maybe getting that 2 all the way from over here, you see that? As the x input. I don't know which value of x is coming from. That's a problem, obviously. So for that reason, we cure that problem, so to speak, simply by doing the following. We drop the pieces that cause that, and we leave just the basic piece right here. So these are all steps towards the tangent inverse function. Now, as you look at this, you see that, for example, since this is a y-coordinate of 2 right here, I can look over to the graph and back to the x-axis, and that will tell me what the value was that was input into the function in the first place to give a y-coordinate of 2, you see? And there's only one such value of x right here, roughly speaking. I don't have to worry about finding another value of x that's doing that. So with that in place, I'm going to relabel the axes. I get rid of my horizontal line here. The vertical is called output, the horizontal is called input. And let's take a look here. What I'm going to do is I'm pretending I'm plugging in a particular value of x. So that's why this here says x sub 0, a particular value of x essentially. So when I feed that into the function, it's going to look like this. You basically hit the curve, you bounce off the curve, and that gives you a nice output along the vertical axis. So this output here is named, as you can see, tan of x sub 0. So x sub 0 goes in, tangent of that value comes out. But again, the key is this. There's nothing special about reading a graph from the input to the output axes or from the horizontal to the vertical. It's just made up. Somebody made that up. So what is that telling us? It's telling us that we can switch things around. Take a look. For example, those dashed yellow lines are the vertical asymptotes. I have a separate video on asymptotes. What it means for us, of course, is simply that these are lines that the red graph never crosses. That's what it means to be an asymptote. And if you look up here specifically, when you draw the vertical asymptotes, you should really be careful because up here, in this position, there should always be a small gap right here. See where the little red pointer is? So always leave a gap between the graph and the vertical asymptote on that side and this side for basically pretty much all vertical asymptotes. So with that in place, the next goal is to do this. Take a look. I'm going to switch the way I read this. Again, I want to stress this. Nothing important or in nature that says you got to read from the horizontal to the vertical. It's made up. Which means we can switch what we call input and what we call output. And for that reason, now this graph here, the red piece would be renamed tan inverse of y. So in other words, what it's saying is that now, because this is tan inverse of y, it's essentially saying take the y values from here and then feed them through the curve back down to the x-axis. So the inputs are now the vertical and the outputs are on the horizontal. Okay, so from there, next step is to actually do this. So imagine y sub 0 is a particular input. And that's going to give us tan inverse of y sub 0 as a particular output. So if you think about the tangent and the tangent inverse, if you know how to read them either from horizontal to vertical or vertical back to horizontal, that's all you really need. Because we normally, by convention, read graphs from horizontal to vertical. We wouldn't leave it in this form. We had to transform it somehow so it looks like the conventional graph, okay? So let's actually do that. A way of doing that would be to do this. We can spin things around a little bit. Take a look. So you're going to turn it this way. That's almost the graph of the basic inverse tangent function, but not quite. Now we rotate it this way. Give it a spin, and that pretty much looks like the standard tangent inverse function gotten completely from the tangent function. The only issue is that here, for example, if we keep symbols aligned with the previous step, then this would be in the input, this would be a particular value of y, this would be a particular value of tangent inverse of y, and that would be the output. And that's okay. The only thing is, again, for the sake of convention, when we look at the graph of the tangent inverse, usually the input values are named x and the output values are named y. So we just relabel things, give them new names, in other words. What I mean is this, take a look. Take a look. So it's going to look like this. I'm going to call that x sub 0, not y sub 0 anymore. So this thing above my head is what I've just changed to x sub 0. Let's take a look at the next bit. So then, this right here. So then the horizontal axis has to be renamed x and not y anymore. And then lastly, as you can imagine, the output would not be called tangent inverse of y sub 0 anymore, but to keep convention, it would be called tangent inverse of x sub 0. But I don't want you to forget something essential here. That is, this step is somewhat arbitrary. And as long as you know basically that the function has to be one-to-one, in other words, it passes, the vertical and horizontal line test and all that, then you can drop off the other pieces and just read the function from the vertical back to the horizontal, and that's pretty much reading the inverse function, and that's it. And this other stuff, that's just so, it makes it look conventional and more familiar, and kind of perhaps works for us better psychologically. And maybe it does, maybe it doesn't. I personally don't like this, having to flip these things and all that. That's a matter of preference. Thank you so much for watching. I hope it's been helpful and insightful. Please leave a like and subscribe, and I will see you in another mathematical adventure. I don't want this to sound cheesy.